Hello everyone, my name is Chaitanya Mishra and I'm a student at Binghamton University pursuing my Masters of Computer Science.
Hi everyone, my name is Nayanpreet Chhabra and I'm currently pursuing my Masters in Information Systems from Binghamton University.
Today we will be presenting our research titled How does the seasonal transition from dawn to dusk affect the number of car crashes in New York City? This research is the part of Transportation Data Science project under the Northeast Big Data Innovation Hub and National Student Data Corps. New York City experiences drastic seasonal differences in sunset times, and these shifts can significantly impact driving conditions. The transition from daylight to darkness affects visibility, driver reaction time, and overall road behavior. The motivation for this study came from a critical question. Does the reduction in daylight hours directly impact the number of crashes occurring in New York City? And if so, how? Understanding these patterns can lead to improved traffic regulations, better route lighting process policies, and increased driver awareness programs. To analyze this phenomenon, we used New York City Motor Vehicle Collisions dataset from the Department of Transportation. And this dataset spans multiple years and contains information on crash date, time, location, season, and sunset times. We focused on the following analytical approaches: time series analysis to track crash frequencies before and after sunset across seasons, heat maps to visualize high crash density areas across different boroughs, and bar charts to compare crashes during different seasons and times of the day. Additionally, we defined the day to night transition period for each season as follows. For winter, we defined it as 4 p.m. to 8 p.m. For fall, 5 p.m. to 9 p.m. From spring, 6 p.m. to 9:30 p.m. And for summer, 7 p.m. to 10 p.m. These time frames were determined based on average sunset times and traffic flow patterns.
So let's start with what our analysis revealed. We have several key insights. The first one is seasonal variations in crashes before and after sunset. Starting with fall and winter, the higher crash rates were after sunset due to the shorter daylight hours and increased darkness during peak traffic hours. While in spring and summer, the more crashes were during daylight, with longer days reducing the proportion of nighttime crashes. The second key insight was at borough-wise nighttime crash hotspots. As we can see that the Brooklyn and Queens experienced the highest crash densities after the sunsets, while in Manhattan the crashes were more concentrated in high traffic intersections. Now, let's move on to the most common crash types. We found out that the most frequent types were the car-to-car collisions, which peaked on the winter nights, while the pedestrian and cyclist crashes increased during dusk in fall and winter, indicating the visibility issues and unsafe crossings. Now we focus upon the vehicles that were involved in these type of crashes. We found out that the sedan and SUVs were involved in 70% of all crashes, while the trucks had fewer crashes but the higher severity per incident. While talking about the motorcycles, the most nighttime fatalities were due to the low visibilities, and cyclists and pedestrians are at highest risk during fall and winter nights. On the basis of these findings, we have some recommendations that can be used to prevent these accidents, which we propose data-driven safety improvements. So, the first one is that we can enhance the street lighting, increasing the lighting in high crash zones, especially in Brooklyn and Queens. While if we introduce lower speed limits after the sunsets in high risk areas, it can also prevent some accidents. For pedestrians, the visibility programs can be promoted reflecting by promoting reflective gear usage and installing more crosswalk lights. The AI-based traffic monitoring could also be a huge help. We can deploy machine learning models to analyze crash-prone intersections and issue real-time safety alerts. So to conclude, we can say that understanding how daylight transitions impact crash rates can drive policy changes, infrastructure upgrades, and public safety initiatives. Our finding emphasized the need for targeted nighttime road safety measures, particularly in fall and winter, to reduce overall crashes in New York City. This research highlights the power of data science in transportation safety, showcasing how seasonal and environmental factors play a crucial role in road accidents. We hope that our findings and recommendations can help us save some lives. Thank you.
Thank you.